In this lecture, I'll provide a step-by-step guide to conduct the analysis we outlined in the previous lecture on Intuition 2. Again, let's open the dataset. And quickly, what the Intuition 2 in the previous lecture says is this. So if one of these biomarkers predicts risk of cancer, for example, let's say the higher value of CEA, the higher the cancer risk. Then if we sort all these patients according to CEA from smallest to largest, then we should see more ones sinking to the bottom and more zeros floating to the top. Again, ones are the cancerous patient, zeros are the benign patient. So this analysis we are about to cover is the process of quantifying that visual impression, and further we'll provide a benchmark with a column of random number. Let's first use filter to sort the dataset by CEA ascendingly. Next, we need to provide a risk estimate for patients in different range of CEA values. So we can do so by dividing the patients into 10 groups of about equal size. So this grouping can be done dynamically by using this formula. Equal, round up, row, parentheses, divided by 26, 0. I would explain what this formula does shortly. Let me first name this new created column group. So now let me explain how this formula works. So there are about 260 patients in the dataset. I want to group them into 10 groups, so about 26 people per group. So roughly, there should be about 26 people in group 1, and then 26 people in group 2, so on and so forth. So let me again click on the formula. So here, the first function we use is the row parentheses. So it is an Excel function that tells you at which row your current active cell is. So that's what row function does. Round up function is the function that rounds up a number to a single digit. So for the reason that I specified 0 is to tell Excel that I want to round up the numbers here into single digit. If you want to round up a number to say the first decimal, you would change 0 to 1. Therefore, by dividing the current rows that we are at by 26, which is the size of group, then round up to the single digit, I can get to which group the current cell should belong. So for example, let's just look at this arbitrary row, row 64. So if you divide 64 by 26, it's going to be equal to around 2.5. And so if you round it up to single digit, it will give you 3, which is the correct group that I want to assign this particular row to. So again, 26 will control the size of the group. If you want to, say, divide the dataset into 20 groups instead, then you will need to change 26 to 13. Now let's run a quick pivot table to check the size of each group we just created. Again, I will insert a pivot table into the existing sheet right here. So I would drag the group column that we just created here, and again I will use class, and then I'll do the change it to counting. Notice because I ignore that the header row takes up one row, so that actually group 1 has only 25 people. And because there are only 255 patients, which is not a multiple of 26, that's why we only have 22 patients in the very last group. Let me drag 2 more columns into the value areas. I will drag again the class Y here, and then this time I will change it to average. I would drag CEA down here. I would also change it to average. Let's look closer to make sense what average of class Y tells us. So let's look at the first group. So in order to calculate the average class Y for the first group 1, we will need to sum up all the value of class Y in group 1, which are highlighted. And since there's only one patient in group 1, so the sum of this group will be simply 1. And then once you divide it by 25, it will give us the average, which will be 0.04 or 4%. So this can be understood as the risk of cancer in group 1 is 4%. So similarly, let's look at group 2. Group 2 are here. So out of 26 patients, there are 7 ones, so there are 7 cancers case, which gives the average of about 0.2692. So this means about 27% of patients in group 2 are cancerous. Therefore, the risk level for group 2 is about 27% as well. So the average of class Y can be interpreted as the risk level for each group. The average CEA is simply the average of CEA values within each group. And since we sort CEA ascendingly, we would expect the value of this column should go up, which is the case. We can also see the average, as the average CEA goes up, the overall trend of risk also goes up. Notice this already provides a rough prediction of cancer risk based on CEA. For example, we can say if a patient has a CEA level around 9.5, the estimated risk of cancer will be around 76.9%. Let me now copy the average risk based on the ascending level of CEA and save it as value here for later comparison. So this will be risk based on, let me just say, CEA based risk. Now I would remove the CEA column for now. I will now add a column of random number as benchmark. So I will use function rand empty parentheses. Double click. So notice this function will constantly refresh itself by generate a new set of random number. So for our analysis, I would copy them and then save as values so they don't change. save as value. Now I am going to name this column random. I would remove this column. Now I need to go to pivot table to make sure I will include this new column in our analysis. I can do so by, so notice once you click on the pivot table, this pivot table tools become active, so you can click on analyze, on change data source. Now it will allow you to redefine the range of raw data. I'll now repeat the same exercise we did for CEA to get a group risk based on this random column as a benchmark. So I need to first turn on filter, and I will reselect filter. Now I'm going to sort the data set using the random number, smallest to largest. Notice the pivot table itself hasn't changed because we need to refresh. We need to refresh it. You can go to analyze and refresh. Click on refresh. Now notice the average class Y, which is our risk estimate, has changed already. Now let me make sure to also drag random number here, and then I would again change it to average to make sure that we understand all these different moving parts. So these results tells us that if I sort the data set in the ascending order of a random number, these are the resulting risk for each group. So again, let me copy and paste them as value. I would paste it here as value. So this will be our random benchmark. So now I can do the same thing using the other three biomarkers. So now I would sort the data set ascendingly based on AFP, smallest to largest. Again, notice that this hasn't changed yet because we have not refreshed it yet. Go to analyze and refresh the data. Now this column tells us the group risk based on AFP. We can similarly produce a group risk level based on the sorting results of the remaining biomarker. So one thing to pay attention to is to always reshuffle the data set with this random column before using any particular biomarker to sort. So the reason is, for example, if I don't first reshuffle by this random column and sort immediately using the CA125 after the AFP, the end result is actually the combined effect of first sorting by AFP, then by CA125. That is not what we want. We want to see the predictive power of each biomarker individually. So let me quickly finish the remaining two biomarker properly. I would again first sort by the random number, so the data set gets reshuffled again. Now I'm going to sort by CA125, again from smallest to largest. I will now go to the pivot table, make sure I refresh the table to capture the effect of CA125 sorted ascendingly. I'm going to again copy and paste as value. So this will be the effect of CA125. Now I will go back to the random column to again reshuffle the data sets to erase the residual effect of CA125. Now again, I'm going to sort based on the very last biomarker CA50, smallest to largest. I will go back to the pivot table, analyze to refresh the results. So now this will be the effect of risk. I'll copy and paste as value. So this will be the effect of sorting based on CA50. Now let me change these data point to percentage because that is what they meant. I will also represent these 5 columns of percentage with line charts to better make sense of the results. So here we have it. This is the group risk based on CEA sorted ascendingly. So the trend is quite clear. And the blue line, the dark blue line, is the group risk based on a random number. And notice because every set of random number will be different, therefore you will always see a different fluctuating trend. And again, you can see there's a slight overall rising trend based on CA50. For AFP and CA125, it's up and down, so it's almost the same as the random benchmark.